One can do coding with AI. However, learning to code is basic training for anyone. There are many programming languages. Python is one that is widely used and easy to run. This is why we teach Python programming, especially for young people and beginners. In this course, you will embark on a journey to learn the fundamentals of Python coding, a powerful programming language used for web development, data analysis, artificial intelligence, and more. Python is beginner-friendly, with a simple syntax that makes it easy to learn and use. By mastering Python, you will not only enhance your problem-solving skills, but also open doors to a wide range of career opportunities in the tech industry. Throughout this course, you will be introduced to basic concepts such as variables, data types, loops, conditional statements, functions, and more. You will work on hands-on coding exercises and projects that will reinforce your understanding of these concepts and help you build a solid foundation in Python programming. By the end of the course, you will have the knowledge and skills needed to write your own Python programs and tackle more advanced coding challenges with confidence. Everyone can code and program. In this course, Python Coding First Step, you will be introduced to the basics of Python programming language. This course is designed for beginners with little to no experience in coding. By the end of this course, you will have a strong foundation in Python coding and be able to create simple programs and scripts. The structure of the course is divided into several modules, each focusing on different aspects of Python programming. You will start by learning about variables, data types, and basic operations in Python. Then, you will move on to control structures such as loops and conditional statements. Finally, you will explore functions, modules, and how to work with files in Python. You will have plenty of exercises to make learning more fun and thoughtful. This class is absolutely for everyone, including young people with absolutely no prior experience. Before diving into Python coding, it is essential to set up the necessary environment to ensure smooth workflow. The Python environment includes the installation of Python Interpreter and Integrated Development Environment (IDE), and any additional packages or libraries that may be required for coding. To set up the Python environment, start by going to Python, org and use the Run window. Nothing else is needed. Further, you will set up your own space in W3 School. It is that simple. There is no need to be bothered by complicated systems for beginners. Python is a popular programming language known for its simplicity and readability. In this lesson, we will explore the basic syntax of Python and learn how the Python interpreter works. Understanding the syntax and interpretation of Python is crucial for writing efficient and error-free code. Python code is executed line by the Python interpreter. It runs from top to bottom once. We will learn about keywords, identifiers, comments, and white spaces in Python code. Additionally, we will cover the use of data types, variables, operators, and expressions in Python programming. By the end of this lesson, you will have a solid foundation in Python syntax and interpretation. In this lesson, we will dive into the fundamental concepts of variables and data types in Python. Variables are used to store data values, while data types specify the type of data that can be stored. Understanding how to declare variables and work with different data types is crucial for writing effective Python code. Python supports various data types including integers, floating point numbers, strings, lists, tuples, dictionaries, and more. Each data type serves a different purpose and has specific functions and methods associated with it. Learning how to manipulate these data types will enable you to perform a wide range of tasks in Python programming. By the end of this lesson, you will have a solid understanding of how variables work in Python, how to assign values to variables, and how to work with different data types. This knowledge will provide you with a strong foundation to build upon as you continue your journey in Python programming. In this lesson, you will learn about the basic building blocks of Python coding, operators, and expressions. Operators are symbols that perform operations on variables and values, while expressions are combinations of variables, values, and operators that produce a result. Understanding how to work with operators and expressions is crucial for writing efficient and effective Python code. You will explore different types of operators such as arithmetic, comparison, logical, assignment, and bitwise operators. By mastering these operators, you will be able to manipulate variables, perform calculations, and make decisions in your Python programs. Additionally, you will learn how to create complex expressions using a combination of operators to achieve specific outcomes. Today, we're diving into two of the most fundamental concepts in Python programming: input and output. Think of it like a conversation. You say something to your program, that's the input. Then your program says something back, and that's the output. Getting this right is key to building awesome, interactive applications. So, how do we get information into our program? The most common way is using the input function. It's super simple. You can use it to ask the user for their name, their age, or any piece of information you need. The program will pause, wait for the user to type something, and hit enter. And then it stores that information in a variable for you to use later. It's like giving your program ears to listen to the user. Now, once your program has done its magic, how does it show you the result? That's where the print function comes in. You've probably seen this one a lot. Print is how your program talks back. You can use it to display simple text, show the value stored in a variable, or even present the results of complex calculations. It's your program's voice. But just printing raw data isn't always the best. You want your output to be clean, readable, and easy to understand. That's where formatting comes in handy. Python gives us powerful tools like fstrings to neatly combine text and variables. For example, instead of just printing a number, you can print a full sentence like, "The final result is ... followed by the number." This makes your program so much more professional and user-friendly. By the end of this video, you'll be a pro at handling both input and output. You'll know how to ask for user data with the input function, how to display information with the print function, and how to format your output to make it look great. Mastering these skills will open up a whole new world of possibilities in your Python journey. So let's jump right in and start coding. We'll go through some practical examples, step by step, to make sure you understand everything clearly. Make sure you have your code editor open and ready to follow along. Thanks for watching, and if you find this helpful, don't forget to hit that like button and subscribe for more Python tutorials. In Python, conditional statements are used to make decisions in code based on certain conditions. The most common type of conditional statement is the if-else statement, which allows the program to execute different blocks of code depending on whether a specified condition is true or false. This allows for greater flexibility and control in programming, as the program can respond dynamically to different situations. With if-else statements, you can control the flow of your program by setting conditions for when certain blocks of code should be executed. The if statement checks if a condition is true, and if it is, then the code block inside the if statement is executed. If the condition is false, the code block inside the else statement is executed instead. This allows for branching logic in your code, enabling your program to take different paths depending on the input or other factors. By mastering the use of if-else statements in Python, you can create more sophisticated and responsive programs that can handle a wider range of scenarios. By understanding how to structure and use conditional statements effectively, you can add a powerful tool to your programming toolkit that will allow you to write more efficient and robust code. In this lesson, we will explore logical operators and comparisons in Python. Logical operators are used to combine conditional statements, and comparisons allow us to compare values and determine the relationship between them. Understanding these concepts is crucial when writing efficient and error-free code. Logic variables include yes and no. For example, is an apple bigger than a grape is a logic operator, and the value is yes, or logic 1. In this lesson, you will learn how to implement decision-making in Python using conditional statements. Decision-making is a crucial aspect of programming as it allows the program to execute different sets of instructions based on certain conditions. By the end of this lesson, you will be able to create if statements, else statements, and elif statements in Python. We will explore how to use comparison operators such as equals, equal to, equals not equal to, greater than, less than, equals, greater than or equal to, and equals less than or equal to create conditions in Python. You will also learn how to use logical operators such as and, or, and not to combine multiple conditions in a single if statement. Additionally, we will cover the concept of nested if statements to handle more complex decision-making scenarios. In this lesson, we will dive into the concept of loops in Python programming. Loops are essential for automating repetitive tasks and iterating over a sequence of elements efficiently. We will focus on two types of loops: for loops and while loops. The for loop is used to iterate over a sequence, such as a list, tuple, or string, and execute a block of code for each element in the sequence. On the other hand, the while loop continues to execute a block of code as long as a specified condition is true. Understanding how to use both types of loops will enhance your ability to write efficient and concise Python code. In this lesson, you will learn about loop control statements in Python, specifically the break and continue statements. These statements are used to alter the flow of execution within loops, allowing you to control when to exit a loop or skip iterations based on certain conditions. Understanding how to use these statements effectively can help you write more efficient and flexible code. The break statement is used to exit a loop prematurely before the loop condition is met. When the break statement is encountered, the loop is terminated immediately, and the program execution moves to the next statement after the loop. On the other hand, the continue statement is used to skip the current iteration of a loop and continue with the next iteration. This can be useful when you want to skip certain values or conditions within a loop. Hey everyone, and welcome back to the channel. Today, we're diving into one of the most fundamental concepts in Python, loops. Now, I know what you might be thinking: loops sound a bit technical. But trust me, they are super useful, and you probably interact with systems that use them every single day. So what exactly is a loop? Imagine you need to tell your computer to do something over and over again. Instead of writing the same line of code 100 times, you can just use a loop. It's like telling your computer, hey, keep doing this until I tell you to stop, or until a certain condition is met. This saves a ton of time and makes your code much cleaner and more efficient. Think about your music playlist. It plays one song after another, right? That's a loop in action. Or when you're scrolling through your social media feed, new posts keep loading as you scroll. That's another loop. There are two main types of loops in Python: for loops and while loops. A for loop is perfect when you know exactly how many times you want to repeat an action. For example, if you want to print the numbers from 1 to 10, a for loop is your best friend. A while loop, on the other hand, keeps going as long as a certain condition is true. It's great for situations where you don't know the exact number of repetitions in advance. Now, let's make this real with a cool example. Imagine we're building a smart traffic light system. A traffic light has a simple, repeating cycle: green, then yellow, then red. And this cycle needs to run 24/7. This is a perfect job for a loop. We can use a while loop to make the system run indefinitely. We'd set it up as while true, which means it will never stop on its own. Inside this while loop, we'll have our sequence of lights. First, we'll set the light to green and maybe use a timer to keep it green for, say, 30 seconds. After 30 seconds, the code moves to the next step. It changes the light to yellow for a short period, maybe 5 seconds. Finally, it switches to red for another 30 seconds. Once the red light duration is over, what happens? The loop starts all over again from the beginning, turning the light back to green. This simple loop ensures that traffic flows smoothly and safely all day, every day. And this is just one example. They are the workhorses that handle repetitive tasks, making complex applications possible. So, next time you're waiting at a traffic light, you can think about the simple but powerful loop running behind the scenes. It's these core concepts that are the building blocks of all the amazing technology around us. I hope this gives you a clearer picture of what Python loops are and why they are so important. In this lesson, we will explore the practical applications of loops in Python coding. Loops are an essential concept in programming that allow us to execute a block of code repeatedly. Understanding how to effectively use loops can help us automate tasks, iterate through data structures, and solve complex problems efficiently. We'll cover different types of loops such as for loops and while loops, and discuss when to use each type. Additionally, we will delve into practical examples of how loops can be used in real-world scenarios, such as processing data, generating patterns, and performing calculations. By the end of this lesson, you will have a solid understanding of how loops work and be able to apply them effectively in your own Python projects. Imagine you are tasked to build a smart crossroad traffic light system. It seems easy and mundane, but it is a good exercise. How would you build it? First, let's define the core logic. The system needs to manage traffic flow efficiently and safely. The basic principle is to give green lights to waiting traffic, but never to conflicting directions at the same time. Our smart system will use sensors. We'll place induction loops under the asphalt on all approaching lanes. These detect the presence of vehicles. We'll also add cameras with computer vision to identify pedestrians and cyclists waiting to cross. The control logic works in states. The default state is a main road green light cycle. When a vehicle is detected on a side road, the system logs a request. If pedestrians are detected, their request is also logged. After the main road's green light has been active for a minimum time, the system checks for pending requests. If there's a request from a side road or a pedestrian, it initiates a transition. The main road light turns yellow, then red. Then the system grants the green light to the side road or the pedestrian crossing. The duration of this green light is dynamic. If the sensors detect a long queue of cars, the green light is extended. Once the queue is cleared, or a maximum time is reached, the cycle ends. The side road light turns yellow, then red. Safety is paramount. There is a mandatory all-red phase of a few seconds between conflicting green lights to clear the intersection. The system also has a fail-safe mode. If a sensor fails, it reverts to a simple fixed-time cycle to ensure traffic doesn't grind to a halt. Finally, for even smarter control, multiple intersections can be networked. They can synchronize their cycles to create green waves, allowing a platoon of cars to pass through several intersections without stopping. This optimizes traffic flow over a whole area, not just one crossroad. That's the basic logic of a smart traffic light system.